All right, let's go ahead and work through some of the 1.10, 1.11 defining and justifying continuity DeltaMath assignments. So first, it looks like you're just identifying types of discontinuities. So for the function below, state all values of x in the open interval for which the function has a removable discontinuity. So I see one at -3, I see one at an x value of 0, I see one at 6, this one at 7, be careful, that's a jump. So I need to do -3, 0, 6. Yeah, that's good. Cool. And then again, it goes through and I'll kind of highlight it for you and explain it, right? All right, let's look at this one. This time they want to know wherever I have an infinite discontinuity. So basically wherever I have a vertical asymptote. And it definitely looks like I have one at -2. I think that's the only one, right? Beautiful. See, these ones are easy. Okay. All right, let's go ahead and try this second set, demonstrating continuity from a graph. Okay. Use the definition of continuity to determine whether the function graph below is continuous at a particular x value. Okay, so at x equals -1. Okay. All right, we got to fill in lots of things here. So it says that we're going to, at -1, since the left-hand limit equals, let's see, my left-hand limit equals -4, and my right-hand limit equals 1, it can be determined that the general limit does not exist. Furthermore, it can be seen that f of -1 is actually at the value of -4. Therefore, it can be stated that the function f of x is not continuous at x equals -1 because your general limit does not exist. The limit as x approaches -1 does not exist. So you just have to fill in all the pieces of information and really work on justifying your answers. This is awesome. Cool. I do like that sometimes it gives you visuals for this. So like, look, it's showing you your left-hand limit, and then it's going to show you your right-hand limit and kind of go through the step-by-step process of it. All right, let's try another one. So use the definition of continuity to determine whether the function f of x graph below is continuous at x equals 5. Okay, so at x equals 5, your left-hand limit as I approach 5 is -1. Your right-hand limit is also -1. So it could be determined that your function, or your general limit, exists and is equal to -1. Furthermore, it can be seen that f of 5, well, if I look on the graph, I don't actually have a point for f of 5, so f of 5 is undefined. Therefore, it can be stated that our function is not continuous at x equals 5 because, scroll down a little bit, the limit as x approaches 5 is equal to f of 5. Nope. The limit as x approaches 5 exists but does not equal f of 5. Yes, that would be it, right? Because my limit exists, but it's not equal to f of 5. There we go. I like those ones. I'm going to try one more, just for fun. All right, let's talk about use the definition of continuity to determine whether the function f of x graph below is continuous at x equals 4. Okay, so as I approach, 4 is over here. Silly me. My left-hand limit is 0. My right-hand limit is -5. So my general limit does not exist. Furthermore, it can be seen that f of 4 is not a point, so we would say is undefined. Therefore, it can be stated that the function f of x is not continuous because your limit does not exist. Cool. All right, if you have questions on this assignment, go ahead and let me know.